This is 9.1a of algebra. So we're going to be talking about quadratic functions, which is this right here. Anything that can be written in that form where a isn't 0, okay? So a, b, and c are other numbers. And it's really similar to what we've been working with, which is on purpose. And we're going to start looking at their graphs, okay? When it's written in this form, this is called the standard form, okay? Here's 3 different examples of it. It has to always have that x squared in front. It doesn't have to have the bx or the c. So the parent function, which is like the simplest form, is just x squared. Okay, and that's graphed over here. This shape is called a parabola. That U thing is a parabola. Okay, and parabolas are symmetric. So this line here, where we could fold them over and they'd meet up, right? The line where that happens is called the axis of symmetry. Okay, every parabola has it right down the middle of the parabola. The lowest point or the highest point, so either down here, there's a rough sketch, or up here, is called the vertex. Okay, the vertex is on the axis of symmetry, that line down the middle. If a is bigger than 0, so if a is positive, that front number is positive, it's going to open up like this. Okay, so then the vertex is a minimum. Okay, it's the smallest value, smallest y value. If the number in front is negative, it's smaller than 0, then it opens downward, and the vertex is a maximum point. So, looking at this one, this is opening downward, so it has a maximum point, right? This is the highest your y value would be. This one's opening upward, so it has a lowest point, a minimum point. On our problem here, this is opening up, right? This is the smallest part, so it is a minimum. And we also need to give the coordinate for it. So our x is at -2, and our y is at -3. So the vertex is at the point -2, -3. Okay, we can graph these functions. We're just going to graph the ones right now that are some number x squared, okay? No adding x's, no adding just numbers, okay? And we're going to do that using a table. So let's try our got it problem. I got y equals -3x squared. Since parabolas are symmetrical, we only have to do numbers on one side. So I'm just going to plug in 0, 1, and 2. Doesn't really matter what you go up by, but in quadratics it goes up pretty fast, so you don't want to jump to like 10, 100, that kind of deal. Okay, if I plug in 0, -3, 0 squared, well 0 squared is just 0, right? And 0 times -3, that's just 0. So we get the point 0, 0. -3 times 1 squared. 1 squared is just 1. 1 times -3, well that's -3, so that's the point 1, -3. If we plug in 2, -3 times 2 squared. 2 squared is 4. 4 times -3 is -12. So this is a point 2, -12. So let me graph those. 0, 0, 1, -3, 2, -12. So 2, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and then, so I'm going to use my y-axis there. That's my axis of symmetry, right? Our vertex lies on that. So if this distance here is 1, this distance over here is 1. So my dot goes there. Same down here. This distance is 2. So this distance is 2. So my point goes there. And it is a curved U shape as best as I can. Keeps going, so I put an arrow on the end. And there you go. 3 points is fine to do, and then reflecting them over. Okay, we can tell, based on the equation that we're given, how wide our parabola is going to be. We're not going to look at it and say, okay, it's this wide, graph it. What we're going to do is we're just going to be able to compare them, okay? Kind of surprisingly, or against what you might think, the bigger the number out front, the skinnier it is, okay? Bigger number goes with skinnier. Smaller number goes with wider. The one thing that we don't take into account when we're comparing the widths of the parabolas is it doesn't matter whether it's positive or negative, okay? We're going to ignore if it's positive or negative and then just look at the number if it's big or little. So if we look here, our coefficient on this one is -1. Coefficient on that one is 3. Coefficient on that one is -1/3. They want us to order from the widest to the narrowest. So the biggest, the fattest to the skinniest. So remember I said it's kind of opposite of what you would think. The smaller the number, the wider it is. So this one's going to go first. F of x equals -1/3 x squared. Right, we're ignoring the negative part. Then 1 is the next biggest, so f of x is equal to -x squared. And lastly, f of x is equal to 3x squared. Remember when I said earlier that if it's positive, it faces up, it's a u. If it's negative, it faces down. That's all that the negative symbol is affecting it, okay? So that's why we're just looking at the number and not whether it's negative or positive. And there's your homework.